All right, team, listen up. We're going to walk through one of the most important checks we do on site, the compressive strength test for cement. Now, I want you to get this straight. This isn't just some box-ticking lab exercise. Nope. This is about the safety, the integrity of every single structure we build. What we do right here in this lab, it's what makes sure our buildings are still standing strong decades from now.
So let me ask you a question. When you're out there watching the concrete pour, how do you really know it's going to be strong enough? I mean, how can we be absolutely sure our structures are safe? Well, that guarantee, it doesn't come from guesswork. It starts right here with this exact test. The responsibility lands on us.
And the answer is simple. We don't guess. And we definitely don't just hope for the best. We follow the code. Period. Everything we're about to do is spelled out right here in ISO 4031 Part 6. Think of this as our Bible. We follow it to the letter every single time.
Okay, first up, the ingredients. You've all heard the saying, right? Garbage in, garbage out. It couldn't be more true here. If our starting materials aren't perfect, our final result is useless. So let's get this right. So let's talk about the sand. And no, you can't just scoop some up from the site. We use a special standard sand specified in IS 650. See how it's broken down into 3 grades? Each one is filtered through a specific sieve size. We do this to get total consistency. Every test uses the exact same sand profile, so our results are always comparable.
And here's the recipe for a single test cube. It's dead simple, but absolutely non-negotiable. 200 grams of cement, and then 200 grams of each of our 3 sand grades. That's a perfect 1-to-3 ratio of cement to sand. This exact ratio is the foundation of the whole test. Get it wrong, and you might as well not bother.
Okay, what about the water? This isn't like baking a cake where you just add a splash till it feels right. We use a formula. It's P divided by 4 plus 3, and that gives us a percentage. That p-value, that comes from a whole other test we do to find the cement's standard consistency. The point is, even the water amount is calculated down to the gram. It's all about precision.
Now, I want everyone to look at this number, 27 degrees Celsius plus or minus 2. Burn this into your brain. This isn't just a suggestion, it's the required temperature for the lab, for our materials, for the water, for the curing tank, for everything. If the temperature is off, the results will be off. It's that critical.
Right, ingredients are measured. Now comes the mixing, and I need you all to pay really close attention here because in this step, timing is literally everything. One mistake with the clock and the whole sample has to be thrown out.
We live by what I call the 4-minute rule. Get your stopwatch ready. You start by dry mixing the cement and sand for exactly 1 minute. No more, no less. Then you add our calculated water and start mixing again for a minimum of 3 minutes until it's perfectly uniform. But here's the kicker. If your total mixing time goes over 4 minutes, you're done. The sample is garbage. You have to start completely over. There are 0 exceptions to this.
So as soon as that mortar is mixed, we've got to move fast. Now we're on to casting and curing. This is where we actually turn that mix into the test cube we're going to break. We pour the mortar into these special molds. The size is super specific, 70.6 millimeters on each side. Now you might be thinking, why such a weird number? Well, it's not random. That dimension gives us a surface area of almost exactly 5,000 square millimeters, which makes the final math for calculating the strength way, way easier. It's all designed to work together.
And it's not as simple as just filling the mold. First, it goes on a vibration table for 2 minutes flat. This gets all the air bubbles out. Then, it spends its first 24 hours in a really humid room. We're talking 90% humidity or more. After a day, we take it out of the mold and sink it in a tank of clean water. That's where it'll live while it cures and gets strong. We'll test samples at 3 days, 7 days, and the big one at 28 days.
All right, after all that careful prep and waiting for the cubes to cure, it's time for the main event. This is the moment of truth. This is where we find out if all our hard work paid off. It's time to apply some serious pressure.
And here's another number you absolutely have to get right. 35 newtons per square millimeter per minute. That's the speed at which the compression machine has to apply the load. It has to be constant. If you go too fast, you'll get a fake high number. Too slow, and the result is just wrong. Like everything else, precision is key.
So we take our cured cube, place it perfectly in the center of the machine, and we start the test.
You'll see the load dial climb steadily, steadily, until crack. That's it. That's the moment of failure. And that's exactly what we need. The machine tells us the absolute peak load the cube handled right before it gave way. Okay, the machine spits out a number, the peak load. But we're not done yet. That number is just raw data. Now, it's our job as engineers to turn that data into the final answer, the compressive strength. And the math is actually pretty straightforward. You just take that peak load the machine gave you and divide it by the area of the cube's face. And remember that weird 70.6 millimeter dimension? This is why it's important. It gives us that precise area to divide by. To be thorough, we always test 3 cubes from each batch and then average the results. So let's look at a real example for a 3-day test on a 53 grade cement. The code IS269 tells us it needs to have a strength of at least 27 newtons per square millimeter, and our average from the test, 28.0. So we're clear, we've passed the minimum. And that means the verdict is simple. It's a pass. This batch of cement does what it's supposed to do. It meets the standard. So let's circle all the way back to the beginning. Why does this little pass matter so much? Well, for one, it confirms the cement we've received is actually the grade it says it is. It gives our mix design team the hard data they need, and, most importantly, it's our official green light. It means we can confidently use this batch of cement out on the site. It's the final link in the safety chain. So, I'm going to leave you with a question to think about. We've talked about a lot of numbers today. Weights, times, temperatures, speeds. Before you step up to do your next test, what is the one number you are going to check and then double check? Think about that. Because having that attention to detail, that's what separates a